All right, we're going to take a look at how oceans affect climate. Um, so water has a very high heat capacity. So what that means is water heats up and cools down slowly, and it can absorb large amounts of thermal energy. It takes a lot of energy to change the temperature of water. So therefore, oceans can store and transport huge amounts of energy. Uh, and they influence the weather through the water cycle, right? So they're carrying all of this energy via the currents that we talked about last section, and this has a great effect on climate. So climate is, weather tracked over many, 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 many years, right? Weather is what's happening here and now, right? Today it's going to be nice and sunny. It's a little bit windy. A climate's kind of the long-term thing. So climate measures the temperature and the precipitation over at least about a 30-year period. Climates vary greatly around the world, right? The climate here in Winnipeg is far different from the climate in, say, Australia or Brazil or Spain or anything like that, or even Vancouver or Toronto and the like. So through convection, heat energy is transferred from the ocean surface to the air, right? So the warmer ocean water will heat up the water above it. This causes that warm air to rise. This rising warm air is called a thermal. Thermals will rise until they lose their heat, in which case then they're going to drop back down because they cool and contract, and this causes a convection current. Um, you may have heard of El Nino. These slides seem to be in the wrong order, so bear with that. Just kind of check your notes. El Nino is the warming ocean effect that occurs some years in December off the Pacific coast of Ecuador. Um, this can change the weather around the world, including warmer, wetter summers in BC, warmer, drier summers on the prairies, droughts in Africa and Australia. These changing ocean temperatures will also cause sea life to change their behaviors. La Nina is a cooling of the ocean water in the same area and produces almost the opposite effect of El Nino. So in a La Nina year, we would have a wet, cool summer. Uh, so oceans can make cold northern locations warmer. Um, Locations like BC, Norway, England, other coastal regions benefit from this. Because of water's high heat capacity, heat energy can be carried from the south to the north by currents like the Gulf Stream. So that carries warm water from around the equator up and across the Atlantic to England and Norway, or the Pacific Drift, which brings warm water up the Pacific coast to BC. So as warm water evaporates, it carries energy with it over the mainland of the province. Now, mountains block the warmth from reaching the interior, right? The Rocky Mountains do a very good job of blocking that warm, moist air from making it to Alberta, right? The western side of the Rockies sees a lot of snow. That's why a lot of the ski resorts are on that side. By the time that air makes it over to Alberta, it's very dry, and that's why southern Alberta, especially, is very dry. Um, When we look at, for example, the city of Edmonton, it has an average January temperature of -7 degrees Celsius. Manchester, England, which is on the same latitude roughly, has an average January temperature of +6 degrees. Right, so they're the same distance north of the equator, but Manchester is a lot warmer due to the warm ocean current. So we look at two different cities in BC, Vancouver and Penticton. We see a uh, variance in the amount of rain uh, and also in the temperature.